Hi, this is Brittany Erwin. I'm doing Chapter 7, Number 20. A light spring with force constant 3.85 newtons per meter is compressed by 8 centimeters as it is held between a 0.25 kilogram block on the left hand and a 0.5 kilogram block on the right, both resting on a horizontal surface. The spring exerts a force on each block, tending to push them apart. The blocks are simultaneously released from rest. Find the acceleration with which each block starts to move, given that the coefficient of kinetic friction between each block and the surface is A0, B 0.1, and C 0.462. Here's a picture of what it looks like before and after the blocks and the blocks in the compressed spring, and then afterwards after it's released. So for part A, mu equals 0, and block 1, I'm going to have m equals 0.25 kilograms, delta x equals 0.08 meters, and k equals 3.85 newtons per meter. For force of a spring equals negative kx, but in this case we're going to forget the negative because it works in the same direction as the motion. So F of a spring equals kx, and we're going to draw a free body diagram. N mg, force of the spring, and I'm going to choose my axis to be x and y, and my acceleration to be positive. Some of the forces in the y direction, N equals mg. Some of the forces in the x direction, force of the spring, which is ma, kx equals ma, and a equals 1.232 meters per second squared. I can check my units. I'm going to get kilograms times meters per second squared all over kilograms, and that's going to cancel out, and I'm going to get meters per second squared, so that should be right. And block 2, the only thing that changes is the mass, and it's going to be 0.5 kilograms. Everything else is the same. My free body diagram, N mg, it's acting that way, but I'm still going to set my axis so that it's positive. And then I'm going to get some of the forces in the y is the same as the other one, and the x, same thing, kx equals ma, and when I solve for a this time, I'm going to get 0.616 meters per second squared. So for part B, we're going to have mu equals 0.1. Everything else stays the same. So for block 1, I'm going to have my free body diagram, N mg. I'm going to have the force of the spring, and I'm going to have friction. Some of the forces in the y direction, I'm going to have N equals mg. Some of the forces in the x direction, the force of the spring minus friction equals ma. And I know that since it's in motion, F equals mu n, and we know the normal force is mg, so I'm going to get kx minus mu mg equals ma, and when I solve for this, I'm going to get a is 0.252 meters per second squared. Okay, and then block 2, the only thing different here from block 1 is the mass, and that is going to be 0.5 kilograms this time. The first one, it was 0.25 kilograms. And our free body diagram is going to look almost the same. I'm just going to have the force of the spring and the friction, but my axis is again x and y acceleration, and I'm going to get the same, n equals mg, forces in the x, force of the spring equal, or minus f equals ma, kx minus mu mg equals ma, and this time when I solve for it, for kx I get 0.308, and for friction I get 0.49, and that's greater, so there isn't going to be any movement because the force of friction is greater than the force of the spring, so A equals 0. And for part C, everything else is the same. Our free body diagrams are the same. For block 1, the only thing that changes is mu is 0.462. And so when we work this out, we get kx minus mu mg equals ma. This is going to equal 0.308, and that is going to equal 1.1319. Again, it's greater, so acceleration is 0. It doesn't move. And then block 2, same thing, except the mass changes this time, because we're doing block 2. We have N, mg, force of the spring, and friction, and we're going to get kx minus mu mg equals ma. This time it's going to be 0.308, and this is going to be 2.2638, and it's greater, so a is going to equal 0 again. So basically this is showing us that as the friction gets greater and the force of the spring remains the same, the acceleration decreases, and eventually the object won't move if friction is greater than the force of the spring, and also that the mass also affects it. With a greater mass, it's going to need more force to move it. And that's it.